Good morning, everybody. Nice to see you bright and early. So today we're going to be walking through a series of episodes about Google Earth Engine, and I hope you had a chance to get kind of started with the setup instructions on the screen in front of you. If not, that's okay. We're going to walk through a lot of these steps as we start the tutorial today. So we're going to start in the Geohackweek episodes repository with the Introduction to Google Earth Engine, which is episode 01. And we're going to kind of start leaning a little bit more on these tutorial episodes in the repository, and then we're going to move into the code editor as we go throughout the episode. So this first episode is really short, and it's just kind of to give you an introduction to Google Earth Engine. As we go along, make sure that if you have questions, you can use your red sticky note, or you can also put them in the Slack channel, and we'll try to answer them. So the purpose of today's workshop is not actually to sit here and talk for an hour about all the different cool things you can do with Earth Engine. There are a lot of really cool things you can do with Earth Engine, but instead the purpose of this workshop is kind of give you a chance to dig in and get your hands dirty playing with some code. So I guess to start with, what is Google Earth Engine? Just to give you a brief definition, it's a cloud-based platform for planetary scale geospatial analysis. And so it's a place where you can go and you can look at raster imagery, and you can use vector data, and you can do all different kinds of analysis. And it was originally written for environmental science and other social applications. And so Google Earth Engine's primary user is people like us, disciplinary scientists who want to use some of these computer science tools. And Google has made this platform for us to do that. So why would you use Google Earth Engine? What might you use it for? Because you might be thinking in your head, well, it seems cool, but how can I use it for my research? Two of the most classic case examples of the power of Google Earth Engine are the Global Forest Watch project and the Global Surface Water Occurrence Map. And I encourage you on your own time to follow those links and check out these two projects. But basically, they leverage the entire Landsat archive to do imagery analysis. In the first example, they've made a global map of deforestation that stretches several decades, and that is what this animated map in the browser is showing right now. And you can pan around the globe and look at 30-meter resolution and see trends in deforestation. The Global Surface Water Map just came out this last year, and it's a map of all global surface water occurrence, including seasonality, that was built on top of the Landsat archive. And it's a phenomenal database. And it's in Earth Engine already. It's built using Earth Engine, and it's a really cool resource for researchers. So those are sort of some of the larger global scale applications. If you scroll down a little bit, I kind of came up with a few other use cases that I've seen, or that I've seen other people use in their research. So other things you might want to do is maybe you have some kind of digital elevation model that you want to extract from a global data set. Instead of going through many different websites and sifting to your study area, you can use Google Earth Engine to just clip and cut and extract the raster that you want from one of their existing databases. You could also calculate indices really easily. So NDVI is one of the examples that we'll go through today. You can also calculate a time series, like for example, for precipitation over a study area pretty easily, which is another one of the episodes that we'll talk about. And you can also create models, machine learning models, using some of the primitive algorithms that they have in Earth Engine. So how does Earth Engine work? Those are just a few of the use cases, but what's actually happening? This diagram that I have posted here is a really kind of gross oversimplification of what's happening. But basically, Earth Engine has three kind of key components. It has algorithmic primitives, or functions that they've developed for us to use, and that is a library that's continually growing. They have cloud-based data sets and a cloud catalog that they're adding thousands of images to every day. And then the really amazing part about it is that you go to that data and you compute using Google's cloud servers. And so what happens is you call into the Google Earth Engine application from a couple different entry points, and there's three entry points: the geographical or the graphical user interface, which is very easy, kind of click and point, which I saw some people on yesterday. There's the JavaScript API, which the developers have spent a lot of time making really user-friendly for us, and that's what we're going to learn on today. And then you can also access these resources through the Python API, which is we're not going to talk about today, but I posted some resources in this tutorial if you want to explore that in more detail. And having a discussion about the JavaScript versus Python is a great thing for us to talk about during the break. But today we're going to learn on the JavaScript API because it has very mature documentation. So you might be asking yourself, well, is my data set available in Earth Engine? If you look at this tutorial, I posted a couple different places where you can go and look at either a summary of the data that's there and then also the actual data catalog itself. The remote sensing imagery and other data sets available in Earth Engine it's just astounding. So the entire Landsat archive, MODIS, many derived products related to terrain, land cover, there's world population data, tons of atmospheric data, there's downscale climate grids, and they're adding things all the time. And so I would highly encourage you to go and play around and dig around in the catalog and see what data sets are available, because it's extremely convenient to go in there and find data instead of having to go to 6 different websites to find each of the different data sets. The other thing people always ask is, well, my data set's not in there. How can I get it added, or can I suggest data sets? So you can import and export your own, like, kind of single smaller data sets, which we'll talk about later in the tutorials, but you can also suggest a data set. So in the code editor, if you go to help, there's a suggested data set button, and it'll take you to a page where people can vote data sets. And if your data set's very popular, it'll get upvoted, and then eventually it'll get in the pipeline, and Google will ingest it if they see fit. So you can suggest, and that's how a lot of the data sets that we use, like the watershed boundary data set that we use today, was added because people asked for it. So they're responsive. So kind of just to summarize, Google Earth Engine is for operating on petabytes of imagery in Google's cloud. That's its main superpower. You can export your analysis. You can import and export your own assets, raster and vector data, of course, with some limitations. You can share your own raster and vector data with other people, which is a new functionality. You can embed the outputs in apps, which is what you have seen here. And you can also store, share, and version control your code that you write in the JavaScript API. Google Earth Engine is not designed for really elaborate, beautiful cartography. So you don't come here to make a highly stylized map, right? You come here to operate on lots of imagery. Also, Google Earth Engine, they've done a great job of adding a lot of new vector capabilities in the last year. That's something they've been really focusing on. But the vector data is sort of like has come after the raster data. So a lot of times some of the vector processing procedures that you might want to do might not be as well developed as some of the raster processes. And then finally, Noel Gorelick, one of the developers at Google Earth Engine, and his group has published a paper this year about Google Earth Engine, which I encourage you to read. And he has a wonderful quote that says, "The price of liberation from these details of parallelization is the user is unable to influence them." So if you want to get into really complicated, if you want to kind of do DIY parallelization, this platform might be a little bit difficult for you to use for that purpose. So Google is kind of taking that responsibility away from you, which makes this program really accessible to people who are non-computer scientists. But then on the other hand, you can't really play with some of the things under the hood as much as some of the other platforms, although that's getting better. So that's sort of just a brief introduction to Earth Engine. The next episode that we're going to go through is the code editor. And the code editor is the JavaScript API where you'll go to actually do your analysis in Earth Engine. And so for all of these tutorials, we've posted a static link to the code that we're using right here. And the links will look like this. So if you are a person who has trouble keeping up with the typing, you can click that link and it'll show you all the code that we're going to be using today, already written out. But for this tutorial, I'll go through and I'll actually step through the code step by step by step to help us kind of like learn each of the parts. But okay, so the code editor overview. And what we're going to talk about here is how do I get to the code editor? What is it for? What are some of its key features? So this link, write it in your memory forever, the HTTPS and then code.earthengine.google. If you click on that, that will take you to the code editor page, which is where we're going to do most of our programming. So what I would do is go ahead and open a new tab with a blank code editor for this exercise, and that's kind of where we'll play. And in case you get lost or forget something I said, there's a diagram right here that kind of shows you where different things are that we'll talk about today in the code editor window. And we're going to start with just the main place where you actually write code. Okay, so right here is where you're actually going to write your code. And when we're programming here, we're programming in JavaScript. And in the 0.0 episode, there is some help kind of getting started with JavaScript if this is a new language for you. But I will say, if you know any other programming language, don't be intimidated. There's just a few key differences that you can pick up pretty quickly. So don't be scared by the fact that you're like, I don't know JavaScript, I've never even heard of it. You'll figure it out. So the first thing that we can do in the code editor is we can write a comment. And you make comments in Earth Engine by these two backslashes like that. So this is just a comment. So if you type that in, you want to run the code. So you'll click run, and nothing happens because it's just a comment. So it's sort of boring. the next thing that we can do is we can actually print things. So we don't want to just like save text in there. We want to actually get it to do something. So we'll copy and paste the code over here and we'll print something to the console using the print command. And just a little comment, it doesn't matter which one of these that you use, you just want to make sure you use the same one on both sides of the text that's inside of there, which is a string. Okay, so you can type your print statement, hello world in Spanish, and when you hit run, this run button right here, you'll see over here in the console tab, you get an output, and that output is the string that you just passed through the print statement. So this is how we can print and look at things in Earth Engine, is by using the print statement. And you can print not just strings, but other objects too, as you'll see as we go along. The other thing that you might notice is if you take this off, you'll see a little I over here. And if you put your mouse over there, it's gonna be like, hey, you're missing your semicolon. So the API will make a statement, it'll mark it as incomplete unless you add that semicolon. And there's actually increasing functionality for auto suggestions, which is really handy to know about. And so how you can turn these suggestions on or off is you can go over here and it'll always mark the statements as incomplete, but you can actually get more or less help if you want. So you can have it underline suggestions, autocomplete things, and then you can also enable performance profiling. And I don't want to talk about that right now, but for the speed of today, we're going to leave the first two checked and leave the enable performance profiling unchecked. And that'll give us some help as we're programming. Okay, so now you've written a tiny script. And what you want to do is you want to save your script. So the next section of this tutorial is saving and sharing scripts. And this is a really awesome new functionality that has been developed since I started using Earth Engine. So we've made some changes here, and so now the save is black, like we can save something. So you're going to go ahead and click save, and you are going to click episode 01, GEE, and you can hit OK. And it takes a second to save as it's thinking. Okay, and you should have over here in your scripts tab 3 different categories: private, shared, and examples. And your script should have been saved in your private tab. A couple things about saving is if you haven't made any changes to the script, you'll notice what is up with the button. It's gray. You can't save anything because you didn't make any changes. But as soon as you make a change, this little asterisk will appear that tells you your script is not saved. So you can kind of keep that in your mind as like, oh, hey, I need to save my script. Once you make a change and save it, if you actually go to that script over here, which mine's going to be way at the bottom somewhere, you'll be able to click on the actual script over here where it's saved, and you can see this little arrow, which is the revision history of the script. You can also rename it over there, and you can also trash it. So your script is saved over to the left in that scripts tab, and using that scripts tab, you can go to the file and look at the revision history and rename it as well. So the other really cool and amazing thing that is also new since I started using Earth Engine is how to share scripts. So what you do is you save your script and then you click get link. And you're like, nothing happened. Well, look at the top up here. What you see is when you click get link, it generates a URL. And that URL, if you shared it with someone else who was an Earth Engine user, if they clicked it, it would take them to a static snapshot of your code. And so that's what we provided for you at the top of these episodes, is just a snapshot of the code. It doesn't update dynamically. So for example, if I added a few more lines of code and hit save, I would have to click get link again to get a new link with the new version of the code. So this is kind of like one of the main ways that we share code in Earth Engine, is just send someone that link. And that was kind of the original way that scripts were shared. If you go back to the tutorial, later on we'll talk about the help forum. Getting those links is really important for when you post on the help forum. So the help forum is a great way to get advice and tips for your workflow. And if you post in there and you say, hey, I don't know what's going on with my code, I need help. If you don't add a link, the first thing people are going to say is put a link to your code so we can help you debug. So use that get link button and copy those URLs into your post, and then people can use your code and look at it to help you debug it. All right. Now the other thing that we want to do is they've added another really cool functionality where this is also new. You can actually have shared repos. And so if you go over to your scripts and you go to shared, you should have been able to join the Geohackweek 2017 repo. So there you'll find the codes that Jill and I have written, the complete codes. And so you can also open those up and use those. Jill, when you shared this repo with people, what are their privileges going to be for this session?
So for this repository, everyone has reader access. So you can load and look at it, but you can't save over anything. So if you do want to save any of them in your private repository, if you're making comments that you want to keep, you just make a change so the save button activates and then save and save a new copy to work with there.
Cool. So don't worry about overwriting our episodes. Okay, that's pretty cool. So now we can make a little script, we can save it, we can share it. But what about the data? That's why we're here, right? We want to play with the data. So what we're going to do in this next section is we're going to kind of look at a couple different ways to access and import data from the cloud. All right, so again, you can go to the GEE catalog and search there. You can also search directly from the code editor. So if you go up to the search toolbar, you can search both data sets and places. And so for this tutorial, what we're gonna do is we're gonna load some imagery into the code editor. And what imagery we're gonna load is gonna be the Landsat 8 top of the atmosphere reflectance, which is the reflectance that's measured at the sensor. And how we're gonna find it is we're gonna type in the search toolbar Landsat 8 TOA. And there's a lot of data, so it's like sorting through all of it. And we're gonna select the first one that comes up, which is the USGS Landsat 8 top of the atmosphere reflectance orthorectified. And if you click on it right here, what pops up is a little window with information about the data set. And this is a really important and useful little thing to remember, because you're gonna be using a data set and you're gonna be like, oh, what's band 12? And you can always go back and look at the metadata this way. So you search the data set, you open it up, and you can look at it here. And oftentimes they'll include citations or links to handbooks and things like that, which are helpful. So here we can see what this data set is all about. And we're really lazy and we don't want to write a line of JavaScript code to import it, so we can just click import, which is really nice. That's also a nice functionality that they've added in the JavaScript API. So now what happens is the collection is brought in as a variable into your code editor window, and you can see it right up here at the top, okay? So now we have a new variable called image collection, and it's that USGS Landsat 8 top of the atmosphere reflectance, that whole image collection. Just a little, this is a really handy like getting started thing. This little blue button right here, you can click it and it'll show you, if you were to just write a line of code to import the data set, that's what it would look like. So you can also, if you need to go to a new script, for example, and you want to copy the imports that you have at the top, you can click that little button and you can copy. And so if we wanted to just write it by hand and not use that import button, we would write it by hand like this. And the code editor auto suggestion is going to say, hey, convert it to an import record and put it at the top. So you can hit convert, and now we have two. But we just want to start with the one image collection. So one other thing that we're going to want to do with this image collection is we're going to want to rename it. So we are going to take, up here in the top, you can just click on the image collection. We're going to rename it Landsat 8 TOA. So just to make sure we're all on the same page, this is what my script looks like now. So I've renamed the image collection at the top, and I've imported it, and I haven't ran the script yet, so let's go ahead and run it. And you'll see nothing happens, right? Because we brought it in, but Jill said recently something that I thought was really funny, which is like the API is kind of lazy. Like you can bring it in, but unless you tell it to do something with it, nothing's going to happen. So what we want to do now is we actually want to look at the data set. So let's try to use that same print command to print the collection. So I'm going to say print and then my image collection. So, and just kind of to remember, an image collection is kind of, I think of it as a stack of images, Landsat images. And the really amazing thing about Earth Engine is this is a stack of Landsat images for the whole globe. So you have the whole archive for the whole world that we're going to be trying to look at. So click run. What's happening? Nothing's happening. So this is some error that you might actually run into. And the error that you're getting is collection query aborted. And then if you could read the rest of that, it says like, what's happening is you're saying, hey, print the entire Landsat archive for the whole globe into my browser. And Google Earth Engine's like, no, I'm not going to do that. So one really handy command to know that I use all the time is you can use .limit and then put a number in there, 5 or 1 or whatever. And you can try to run it again. and now it'll print it. So it'll print just the first 5 in the collection. So this is a print command that I use all the time because often I'm working with big feature collections or image collections. I want to know what one of them looks like, and I don't want to know what the whole collection is. And if you try to print the whole thing, it won't let you. So if you go over here to the window, you can see the image collection, and this is the same information that's over here, right? So you can see this is an image collection. Each image is one Landsat image, and you can see what the bands are. You can get more information about the bands. You can also look. So I printed the first 5 images, so that's the first 5 features. So these are each one of the images. And you can look at that Landsat ID here, and you can also look at the properties. And so you can get more information about each one of these images. You can also go into each one of the individual images and look at their properties. And so for this one Landsat image, you can get things like what's the cloud cover in that scene. So this is a really handy way to explore. If you're pulling a variable in and using it, you can print things and kind of take a look at them. All right. So what we're going to do today, so we kind of printed and looked at like the metadata, but we actually want to map and visualize the collection. Now, obviously, we don't want to map every single tile from 2013 to 2017 for the whole world, right? We're interested in one place. Usually, I'm like, what's happening in my study area? So for this next part of the tutorial, I'm going to show you how to manually draw a geometry and then use that to filter the collection. So the geometry tools are in the code editor, and they can be used to draw points, lines, or polygons. And so what we're going to do is we're going to actually drop a point at one of my favorite lakes, and then we're going to filter all the Landsat collection to that point. So let's go here, and in the search toolbar, let's type in Lee Vining. Has anyone ever been to Lee Vining before? On the backside of Yosemite? It's a really beautiful place. We'll search it, and it'll zoom your map to Lee Vining, which is in California, and you can also see there's a lake. So I want to get the Landsat imagery over that particular lake. So what I'm going to do is I'm going to create a point that is over that lake. So I'm going to click over here on this little icon. You could also draw a polygon around it if you wanted, and I'm going to drop that point in the middle of that lake. And one tricky thing you might notice is until you actually click on this, these 2 windows will not appear. So you have to actually start drawing the polygon or the point or the line to get this geometry importance window. So then what you can do is you can open up and you can kind of configure the geometry. So we're going to call this my region of interest, and I'm going to import it as a feature collection. I just do that out of habit. Theoretically, a feature collection should be like several points, but we're just going to do one today to keep it simple. So I've named it ROI. I've made it a feature collection. I'm going to click OK. And the other thing that's kind of a little funny trick you might want to know is you'll notice that it's telling you, hey, you're drawing a point. It's not going to stop drawing a point until you click exit. So go ahead and click exit so you don't accidentally add more points. So now we have this geometry import that's called ROI, and it's a little dot at my lake. And you'll notice that it's also created an import up here, right? So it's programmed it at the top of your imports. All right, so now we've identified our lake of interest, and we've renamed it ROI, and we've cast it as a feature collection. So now what we're going to do is we're going to filter our Landsat archive to just this point. Okay, so there's going to be a couple different steps. We're going to filter it to the point, so we only get the images that are over our area of interest. We're going to filter it down to just 1 year of images. We're going to sort it by cloudiest, right? And then we're going to pick the least cloudy image, which is going to be the image on top of that sorted pile. And so we're going to use this chunk of code right here to do that. So I'm going to go from a whole image collection down to just 1 image, and that 1 image is my least cloudy image over my lake that's been taken during the year of 2016. Okay, so you can copy and paste this over here. And if you have any trouble, you can use the static code, or you can put your sticky note up or ask from the TAs. And click Run. Okay. Yeah.
So do we highlight TOA already in the collection, or what is it?
Yeah, so there's, with this programming, oftentimes there's many ways you could do something. So you could also, if you remember, each image collection has a unique ID. So if you type in Landsat 8 TOA, you go here, you could call the image collection by changing this Sorry, it's really slow. You could change this to a string, and inside that string you could put the name of the collection, and you could skip that import step, like that. But I wanted to show you guys how to import data into the browser, so we imported it, gave it a name, and then we're calling it later in the script. Does that make sense? Does that answer your question?
I was actually just wondering, do you have to, is that e.image part necessary, or can you just cast it straight to the image?
I believe it's necessary. Jill, is that correct? To cast it as,
yeah. First, we're taking basically the image collection, which is the LATOA, or you can do it this way as well. And then from that, we're picking out an image, and you also have to cast that to a Google Earth Engine data set. So you have to explicitly say, this piece we're taking out of the image collection is an image. So that's kind of a little variable.
So go to this image collection and make this image, pull it out. Yeah, run it without and see if it works. Because we did already cast it as an image. It does come in as an image collection up here, so that's a good question. Okay, so we ran this, and it's created this variable image. But once again, we can't see it. We don't know what it's all about, right? So what we're going to do is we're going to print the image. We're going to use a print statement to check what we just made. So print image, and I'm calling it Mono Lake Landsat 8 image. You run, and you can see over here my image is printed, and it's saying, hey, this is your Landsat 8 top of the atmosphere image. Here are the properties of your image. Here are the bands. You can go over here to look at the metadata. So now that we've managed to get this collection down to the area of our interest, to the least cloudy image, we actually want to add it to the map. And so we're going to use this map add layer command right here. And actually, to your question, if you ever are not sure about what a function or command does, you can go over here to the left to docs. And in the docs, you can search. So if you're like map add layer, what are the arguments that it takes? You can type map add layer, and you can scroll down and see what the documentation says about that particular function. So you could read it here. All right, so we're going to add the image to the map using map add layer, and we're passing it the image variable. This is where you define your visualization parameters, and right now we're just going to leave them blank, and we're going to call it our Landsat 8 image. So run the code again, and now you can see over here in the layers that we have a new layer that's been added to the map. Okay, so we can zoom out, and you're like, oh, this sort of doesn't look very good at all, right? It's not really giving us any information once we visualize it. So what we need to do is we need to give it more specific visualization parameters. So what we're going to do is we're going to ask it to visualize specific bands, and then also at a specific stretch. And we're going to call that Better Landsat 8 image. So you can copy and paste that code from the tutorial right in there, or you can type it if you're fast. And we're going to ask to see the true color, the red, blue, and green bands, to make it look like a natural color image. So click Run. And what you can see is that we have a much prettier image now. That looks more like what we want to look at when we're looking at a natural color Landsat tile. Okay, so you're like, well, that's pretty cool, Catherine, but how am I going to know what those numbers are? I'm not going to know that ahead of time, right? So more often than not, you don't know what the optimal stretch is when you add a new image, and you might want to play with being able to visualize it without going in and just randomly guessing what those numbers should be, right? So the developers have added an awesome new tool, which can be found over here. And basically what you do is you come and you click on this little wheel, and over here you can adjust the transparency of the image, and then you can also play with the stretch. So this is a new functionality that is fantastic. You can play with the bands, and you can play with which bands you've selected and the range. And one easy thing to do is just to set it at 1 standard deviation stretch and kind of apply that and see what it looks like. You can also stretch it to 100%, so it'll go from the full min to the max values. And then if you click import, it gives you a dictionary that you can then pass to visualize the image later. So you can just say, hey, take a snapshot of these parameters so that I can call them later in my script. So this is a really handy new tool to help you kind of visualize imagery more quickly. Okay, I think that's good. And the other thing too is that you'll notice that you can turn layers on and off here. And then the last comment I have is that you can toggle between the map and a satellite-based map with these buttons like this. So depending on what you want to do. All right. And then you can see in the tutorial, I posted some more links to guides for the visualization. The other really last few super handy things about the code editor to know about before we dig into like a full exercise is the inspector tab. So if you go over here to inspector, anything that you've used the map add layer to add to the map, if you click on the map when you're in the inspector tab, it'll give you information about that particular pixel that you click on. So I'm going to click on a water pixel, and over here it's going to show me the reflectance for that image that's been added to the map. And you can actually, another really cool new thing they added is you can toggle between just looking at the numbers and looking at a little plot. And if you really like the plot and you want it to look at it in another window, you can do this, and you can do download CSV or the image like that. Which is pretty cool. So you can check out the water and check out the land and see how the reflectance is different in between those two zones. All right, so the last thing last two kind of points I want to hit. I'm not really going to talk much about importing and exporting your own assets because we're going to go through them in some of the tutorials, but you can bring in your own raster and vector data, and you can look at the tutorial, and we'll also practice in Jill's session. And probably the most important thing that I will talk about today that you will learn in this session is where to go to get help. And so there's lots of different places to get help in the code editor, and we've already talked about a couple of them. So over here you have the docs tab, which is where you can search and look at the information about all the different functions. And then this button is extremely helpful. You can click on the user guide. My workflow is like, if I want to do something in Earth Engine, I'm like, well, is there already a tutorial that the developers have made for it? And I go and I try to find it. And then if I can't find it there, then I go and I look on the help forum. And I believe that to join the help forum, there's some extra steps that you guys might need to do. But the help forum is where people have been posting for years questions about Earth Engine, and odds are if you're a new user, the question you have, someone has already asked. So you can use this and search for topics. You can find code tidbits there. Sometimes you can find data sets that people have uploaded privately that they're willing to share. It's a great resource. The other place that you can go for help, besides the developer's guide and the help forum, is there are existing tutorials and Earth Engine for higher education tools that are here on the EDU page. And a lot of the work that we've done today has been adapted from some of these tutorials. There's so many resources for Earth Engine out there now. It's really fantastic. So that's another place you can go to look for information. And then the suggested data set is a great place to suggest data sets if you have one that you want imported. And then also in the help button, there is the shortcuts. So if you're like, I want to know a handy shortcut, they have a new little code editor shortcuts pop out for help with that to increase your coding speed. And then finally, the other place you can go to look at examples, really there's an overwhelming amount of places to find help, is in your scripts repository under examples. There's examples of code tidbits for all kinds of different things. So I think that was everything I wanted to cover. We talked about how to run scripts, save, share them. We looked at where to find help and information on the different things that we're using, and we learned how to load and visualize an image from an image collection. I think that was everything. And with that, what I want you guys to do is, there's a kind of like stop and play. So what you can do is you can play with the visualization parameters and use the inspector to explore the map. You could also practice dropping the point somewhere else, and you could also change the dates and the filtering to look at a different year of the Landsat 8 collection. So if you guys want to play for like 2 seconds while Jill and I switch computers, and she's going to take over and do the next episode. Have fun. Thanks.
So for the next tutorial, we're going to be working, if you go back to the master website for the Google Earth Engine tutorial, we're going to be going to this next one in sequence, accessing satellite imagery. And so in general, these next 4 modules are examples of things that Catherine and I thought are pretty typical uses of Google Earth Engine that might be good resources, but we're only going to have time to dig into the guts of the first one. And at the end, we do hope to have a little bit of time before coffee break, where you can kind of click through the other ones. You already have the whole scripts for them, so you can run them and kind of get interactive help on your own, just looking and seeing what's there. But we're going to spend the next
chunk of time working through accessing satellite imagery. And so here we're really going to be talking about a good example to show the big advantage of Google Earth Engine. So if you were going to be integrating satellite imagery or something into your workflow for your work, chances are your area of interest is going to be larger than a single Landsat scene. This graphic here on the web page is all of the scenes or tiles for Landsat that they distribute. There's 455 of them that cover the United States. And so if you were working in a watershed or a state or a region of the United States, you're going to end up having a lot of scenes that you're trying to incorporate into kind of one image that you can use to get your satellite data from. It's also worth noting that each one of these scenes comes with somewhere between 7 and 10 bands. And so if you remember yesterday in the raster tutorial, we had 2 different TIFFs that represented 1 band each of a Landsat scene. And so if you're wanting to work across multiple bands, across multiple scenes, and then across multiple dates, you can see that the data requirements of that kind of scale up really, really quickly. And so this is really where, kind of, in my opinion, Google Earth Engine really shines. So what we're going to do here is do an exercise, acquire Landsat data for a watershed. And there's a couple links right here. The one to go, if you don't have access to the shared repository, you can click this link that's here at the bottom section. It'll be a static link to the code. Or you can just open the code here in the shared repository 03 accessing imagery. And we're basically just going to be working off of this script. I threw a lot of comments on here to help people kind of follow along and see what's going on. So it's a bit of a comment storm, but hopefully that'll be helpful and not irritating. And so another thing we're going to do, you probably noticed by now you can't run any individual lines on their own. You have to run the whole script. So we're kind of going to just start this out by commenting it all out, and then we're going to uncomment the chunks as we go through and kind of examine what each of them is doing. So a helpful thing to know to do that, under the Help button up on the top right, there's a shortcut menu. And so here are a bunch of keyboard shortcuts that you can use on your computer. I just learned from a recent question that this actually should be platform specific. So if you have a Mac, it likely says Command plus / or / to comment the whole thing out. So hopefully that makes sense to everybody. And so if you select all the text in the code editor and then do that keyboard shortcut to comment everything out, then we'll kind of get through and uncomment that as we go through. Of course, if you prefer, you can just run the whole thing and piece through it as with the group, kind of follow along. If anyone is having trouble getting this code up or with any of that, just pick up your sticky flag and Catherine will come around and check in with you. All right. So the first thing we're going to do is we're going to work with a vector data set, basically to use a polygon to query the Landsat collection and return images in our area of interest. So here you can uncomment this section right here. And we're loading here a vector data set that is already in Google Earth Engine. And so you can find it the same way that we found satellite imagery. If you search watersheds, you would get tables to show up. It might still be searching. So Google, the documentation is great, but it's not always perfect. And so like in this case, what we got from searching watersheds was the HUC 10 level, and there is HUC 6 through 12. So there is a little bit of voodoo involved still, but in general, it's pretty helpful. And that's why the forum's also helpful, because sometimes you don't know quite where to look. So here we've entered the image ID within the code. As Catherine did, we could also import it to the top up there. I prefer to do it in the script, so it's easier to port to different scripts. You can copy the top part that we're using before, but I personally have problems with it sometimes, so I don't do it that way. Okay, so we can go ahead and load this. Hit the run button, or there's a keyboard shortcut for run, which on Windows is Control Enter. Mac probably Command Enter. Oh, and in this case, if you ever want to load something but not have it automatically be drawn on the map, you can hit the false argument there. And so you have to actually click the layer on in order to see it. And we can examine the feature collection just the same way as we did the image collection. Each of the features has properties, much like, so it's basically equivalent to what you would think of as a feature collection like we talked about in the vector tutorial yesterday, or shapefile. Each kind of item has a geometry associated with a whole list of properties or attributes and shapefile lingo. And so you can learn about your data set, what your column headings are, or property names, here by printing things to the console. And then another helpful thing to know as you're going through this, so obviously we know a few of the major commands. If you wanted help on mapping, you can go down to map over here on the docs, add layer, and look into what that is. But there's also a helpful keyboard shortcut for that. Right after you open the function arguments, if you hit it's Control Space on a Windows, so again, perhaps Command Space on a Mac. If anyone finds differently, let the group know. And that'll pull up kind of the documentation right there, and you kind of see what the arguments are that you should be listing. Here it's our EE object, so this feature collection that we call WBD. Viz params are a dictionary, and we're not changing any of them, so it's just empty. And name, and that gives the name on our layer list down here. So that's helpful to know what we're adding soon. Cool, so what we're gonna do next, for this next little bit of code, is we're going to, we're going to filter the watershed layer based on the properties in that layer. So kind of filter the vector data down to just one. And we're going to use the filter metadata command. And so again, if you hit Control Space there, you can see what it's looking for. It's looking for the name of your column. And in our case, that name, So you'll notice also, if you're looking over here on the right, that there are two different ways to see what's in the feature collection. So this column shows the general columns of each feature collection, but you actually have to click the feature and then the individual feature to get the properties of that feature and get the name. So this first watershed here is called St. John, if that made any sense. OK, so this is actually going to be a little bit of a choose your own adventure module, where you can look at whatever watershed is of interest to you. So that's another nice thing about Google Earth Engine. We don't have to kind of preload data that we think people will need. It's all there, and you can query whatever you are interested in. So the Republican River Basin is where I do my work, so that's there for what I'm interested in. And if you want to find a different watershed in an area of the United States that's interesting to you, you can click this inspector tool on the top right. And when this tab is activated, anywhere you click in the map will show its values for all the layers you have loaded. So here's my watersheds layer, and if I look down at the properties, I can get the name Republican. Or if you just know your watershed name, you can filter on that. But it's at the Huck 6 watershed level names. So you're welcome to keep it Republican, or you can kind of choose your own adventure, look at any watershed you like. I did test it for the Puget Sound region as well, and with the kind of sound in there, some of the visualization wasn't perfectly tweaked, so it might not look as pretty, but you're welcome to do that as well. So if we print our new collection, it's still a feature collection, but it just has one. So features list, one element. We're down to just our watershed. And then we can map just the watershed that we showed up. And you can also control how the map loads. So with this command map sender object, we can specify the location on our map that we kind of want Google to automatically zoom to in the zoom level. And so we can map our watershed with that. And so here it zooms to my area of interest is in this confluence of Nebraska, Kansas, and Colorado. Yours could be anywhere. All right, and so the next thing we're going to do is we're going to load everything in the Landsat 8 collection within that watershed for the year of 2016. And so again, you can find this image collection ID by searching for the data set. And we're actually going to use a different, slightly more processed Landsat 8 product, the surface reflectance product. And so the USGS produces these as well on the imagery. It basically is doing an automated algorithm to take it from top of atmosphere reflectance down to the actual surface reflectance. And so theoretically, it should be doing atmospheric corrections to the scenes, which might make them more comparable across scenes and across dates. But of course, if you're ever using this, you want to confirm that those algorithms are appropriate for your study area and study system. It also is really handy because it provides a band that gives it a cloud score. And so it has a band called CF mask, and if it's 0, that means this pixel's good. If it's 3, then it has snow. If it has 4, it has clouds. You can use that to kind of automatically get rid of some of the junk. And so again, we're going to get the Landsat collection ID right there. That's how we know what to load. And then we can use, there's a bunch of different filters you can use if you're ever wanting to know something, what's all out there. Other than the developer's guide and stuff, you can always just browse the docs. So EE filter over here, you can see there's a ton of filters. You can do it on the properties. You could do it by path and row. We're going to use filter bounds for our polygon and then filter date to get that year. And so in this case, I do want to actually print the whole collection because I want to see how many images I'm working with in my watershed. And so it might take a second to run to kind of think through that. So you can see in my watershed, that means 262 scenes fit that criteria. And under each of the features, we can look and get the band names. So each scene has this many bands, and it has the standard Landsat bands and then this CF mask layer. All right, so it's a good time to throw up a red sticky note if you're having trouble, or maybe a green sticky note just to confirm that you're you've printed the Landsat collection for your region. And we're not going to visualize our collection yet because we still just have a smattering of 200 scenes that all overlap each other. So it's kind of hard to get a good visual of that. So what we're going to do is we're going to learn how to process this image collection down to a single image that we can look at and has information that we're interested in. And so basically, there's a bunch of functions specific to an image and an image collection in Google Earth Engine. And so often you want to apply a function specific to images to the whole collection. And so the thing to do that is kind of the standard programming concept would be to loop or apply that function to every element within the collection. And in Google Earth Engine, the equivalent is to use this .map function. If you know JavaScript and you write a standard loop in the code editor, that brings the processing to the browser. And unless it's a super simple loop, you're going to crash your browser and it's not going to work. I don't think you're going to damage your browser, but it just won't work, the code. So .map sends that function to Google servers, and that's where we want all the processing to happen. So in general, in Google Earth Engine, you want to move away from thinking of things like loops and think of using .map to get the actual Google Earth Engine algorithms to be working on your data. Cool. OK, so we're going to do two functions here. First, we're going to mask every single cloud in our collection, and then we're going to add a new band, similar to what we did yesterday in the master tutorial where we calculated NDVI. But we're going to calculate it for our whole collection. So first, you can uncomment this function, and we'll kind of just step through what it's doing. So we're defining a new collection named masked clouds. And the first thing we're going to do, you could kind of smush this all together, but for legibility, we're going to break it apart. So first, for each, as we loop through our image collection, we're going to call each image IMG. And the first thing we're going to do is going to make a new image with just the CF mask band. So select allows you to select a certain band out of your images. If you want to select multiple, you just make it into a list. So you could select multiple bands at once by making it a list instead of a single object, I think. And then, so based on this metadata here for the CF mask, which you can also find up in the handy dandy docs for it, or if you want further reading on exactly what's going on, they have links down here to the Service Reflectance Products Guide. But in this case, we want to keep pixels that are clear and pixels with water. And you're welcome to change that if you don't want to keep water pixels. So basically, we're going to update the mask on each of our images using CF mask band, and whatever pixel in the CF mask band is less than 2, we would like to keep. So there's other math type things we could do. We could do EQ would be equal. So if you just wanted to keep clear, you could say EQ 0. If you wanted to do greater than, it's GT equal. And so all those are over here in the docs panel somewhere. And then you have to tell the function what to return. We wanted to return this max image. And then right here is kind of the actual processing. We haven't actually done any processing yet. So here, we take our original collection that we loaded, and we named it L8 collection up here. And then we're going to map this function map clouds, and we're going to get a new variable, L8 mask. And to kind of see what that looks like, I keep doing that. We're going to uncomment this visualization section. And so here we're going to set this dictionary for visualization parameters. We're going to tell it what bands we want to be red, green, and blue to make a true color composite of our Landsat image based on those spectral bands that it has. And I've kind of preset some values that tend to make sense for surface reflectance imagery. You can start at 0, might actually be better. And so we're going to use the same visual parameters for that. And kind of similar to what we were talking about before, we can slice off the first image from our collection with this .first function, but we have to recast it to an image in order to kind of look at that. So, and then turn, you can either take away the false or we'll just have to turn on the layers. And that was just so it wouldn't keep plotting all this stuff if you were running the whole script. So I want to turn on clouds in original. So you can see this is, this image overlaps my study area, but it is, right now we haven't done any clipping. It's just kind of got in our filter because it is somewhere within our boundary. And the raw image here, it's the first image of the stack, so it's probably a January image, which is why it looks pretty brown and dry. And then it has this massive white mess of something or other, which could be a cloud. I don't know, maybe it was snowy then. I have no idea. But our cloud masking algorithm had flagged all those pixels as being poor quality, and so what we ended up with is this scene that basically is missing all of that. And again, if you're ever using kind of these pre-calculated things, you might want to take a look and make sure it's doing what you want for your study area. I don't know how much you might trust the value of pixels that are kind of isolated in a big cloud field, but to do it on a large scale, it's a helpful way to kind of shortcut. Awesome. Okay, so what we're going to do next is we're going to calculate NDVI. And so, again, we need to make a function, and I've made 2 examples of the functions that do the exact same thing. So get NDVI and get NDVI2 are equivalent functions, but they use different operators that I thought would be useful to know. So so in general, we're going to add a band to each image for NDVI. And we're going to calculate that band by applying, there is already a normalized difference function within Google Earth Engine, so you just tell it what bands. And so if you remember from yesterday, sorry I don't have a reference, the formula for NDVI is NAR, the near infrared minus the red over near infrared plus the red, and it could be the other way around. I'm not sure. Feel free to correct me. Oh, it should say in the next one, which is subtract. Okay. And then we're going to call that band NDVI. It would automatically be called ND for the output of normalized difference, but it can be helpful to rename the band if you are making multiple bands at once. And so that normalized difference is kind of a shortcut for this, but there's also, you can do any kind of band math you want. So we can, in the get NDVI function here, we can first select band 5, and from band 5 we can subtract band 4. And then all of that's going to be divided by band 5 plus band 3. So that's just an example. If you're ever you can do any operations on these bands that you want. But for common operations, there's often a shortcut. And then again, we're going to apply that over our full image. And if you uncomment the print statement for this first scene, you can see that in our band list, we now have the ones that came with it, and then we've added this new one, NDVI, down here. Cool. So why are we calculating NDVI? The reason is my goal here is to make a composite for the region where we have kind of what's called a greenest pixel composite. So it's basically making an image of my watershed for the maximum peak growing season for each pixel. And so we want to do, there's several different ways to make mosaics within Google Earth Engine. We could just say, take the most recent image, valid pixel. And so, for instance, this is 2016. The latest December scene might have some clouds that are masked, and so it would fill in those clouds with the most recent scene before that. Would be kind of a simple mosaic, but we're going to do a little bit more complicated one. It's called a quality mosaic. And what it does is for each pixel, it selects the best set of bands from all the available imagery in our collection based on the value of the band you tell it. So we're going to tell quality mosaic for NDVI, and then here we're going to clip it to our watershed just so we're not kind of carrying along extra things in our visualization. And so again, if we print that, what we've done here is we've gone from our image collection of, I think I had 262 images, and we're going down to just one image. So now we have a single image, and we'll look at it in a second, and we'll see it has full coverage of our region, and it has all of the bands that we were talking about. So if we uncomment the visualization code, here's just an NDVI palette that I found somewhere and copied. You can use hex codes in Google Earth Engine. For common colors, you can just use the text, like red. And so I want to just view this one band. So I'm taking composite, and I'm selecting the band called NDVI. And I'm setting my visualization parameters. NDVI has values from -1 to 1, but here I'm going from 0 to 1. You're welcome to change any of those. We're defining our palette, and then again, we're calling our layer NDVI. And I hit run a little early, but we're also going to make, so we still have all of our bands with this, so we can still make a true color composite, and that's what I'm doing on the next line here, where I'm telling it the red, green, blue bands, and setting values, and we're calling that TCC for true color composite. So hopefully, if you're following along with the Republican River Basin, or if you're doing your own watershed of interest, you now have a wall-to-wall coverage of NDVI for your area of interest. And so because of this quality mosaic, each pixel doesn't necessarily come from the same image as its adjacent neighbors. So in this case, we're getting the greenest pixel. So here in Nebraska, it looks quite green. This is an agricultural region, so particularly this really pops out things like crop circles, center pivot fields. If you click on the TCC image, the true color composite image, you can also look at what looks more of a standard satellite image view. It should take a second to load. Oh, and while that's loading, it's really helpful to comment. The Google Earth Engine is lazy in its execution, so it doesn't do anything unless you tell it to map it, print it, or export it. And it also will only process that unless you specifically tell it the scale. It processes it for the scale of your map viewer. So you could get completely different results if your zoom is different, if you're not using a function that has a scale parameter. That's really helpful to keep in mind. So basically, if you have this loading and I zoom, it's recalculating that kind of on the fly for each of my zooms as I'm panning around. Cool. So we do want to move into our wrap-up section in a second. So I'm just going to kind of do the rest of it here in brute force, just to show you. We wanted to show an example. If you uncomment this next section up through this example, bonus playing with charts. And so here I'm kind of cheating, and I'm loading the MODIS, not cheating, but I'm loading a pre-processed satellite product from the MODIS data set, and it's 250 meter NDVI. And then for that collection, I'm getting the mean value for the whole region. And if you hit run, you can make, actually do kind of interactive. Again, it's not, you won't have the same kind of utilities you'd have in Python where you can really dive into all the chart parameters, but you can take a quick view at what that looks like for our region. And so here in Nebraska, there's a pretty peak growing season, largely associated with crops. And this might just be a bad image, so that's why it's always important in standard products to do some quality assurance. And then there's an example here of how you would take that to actually calculate it and export it. It's within code, but it's also worth noting if you pop out your graph, you can download a CSV of the data that underlines that chart. And then the final example here, and you're welcome to uncomment and run it if you want, is how you would export this image you've now created if you wanted to use it outside of Google Earth Engine or for another script within Google Earth Engine. So that just briefly, this selects the NDVI band from the composite, and there's two options. You can export the image either to your Google Drive. It's kind of automatically linked with your Google Drive. And if you do have Google Cloud Storage and you're working on much larger data sets, you can link it with your Google Cloud Storage with a similar command under the Export tab. You can find it. It'll be Import Image to Cloud Storage. And then another thing to do is export it to your asset folder. So you don't really want to take this data outside of Google Earth Engine and store it locally, but you want to save it for later. And so you can export it to your asset. And up here, you can see I have quite a few assets. And so here you can load these things similar to how we loaded the watershed data set before. So my file path is users / Deines / these folders that I've organized. So you're welcome to go ahead and run it and export it, but if you do that, it is worth noting that when you hit run, it'll generate this export task. And so you'll see this task tab in the top right turns orange. And if you click on that, it lists the tasks that you've told it to run. But to actually run them, you have to then go ahead and again hit the run button. So basically, it's a catch to make sure someone doesn't accidentally send a massive amount of processing through the system without really meaning to as you're developing your script or something like that. And if you do it to asset, you'll have to change users to your username right there. And if you do it to Google Drive, it will create the folder you've named. If it does not, already find that folder somewhere in your Google Drive. Cool. So that's everything we have for the accessing imagery tutorial. And so kind of maybe for the next bit of time, leading up through and into coffee break, we'll go to a wrap-up slide, and you're welcome to either from Google Earth Engine in the shared script folder. You can go ahead and run these other examples and kind of see what they're all about. I do not want to save my changes. The reducers one is, the example is using climate data. So if you're not interested in satellite data, you can really find a lot of resources still here on Google Earth Engine, including climate data sets of past reanalysis products, as well as future climate projections and CMIP runs and that kind of thing. DEMs, and they have functions for calculating terrain and hill slope, and all kind of things like that. So this example is kind of stepping away from the satellite imagery part of it, and just an example of getting annual precipitation by US county and exporting that as a table. And then classifying imagery is an example that goes through how you might make a land use classification map within Google Earth Engine. So it's a fun little example for that. And then the time series code here shows a little bit of some of the same stuff, but particularly there also are ways to make your Google Earth Engine somewhat dynamic and interactive. And this is also if you're making an app, this is kind of a type of stuff you would do. But basically, you can click anywhere in this image once you hit run, and it'll show you the time series of these vegetation indexes at that point. So you're welcome to play around with those. And
for the people who are interested in machine learning, the classification one has a random forest example using the machine learning library from Google.
yeah, and if you're interested in whatever algorithms they have for machine learning, you can check them out under EE classifier. Cool. So just some closing thoughts. We have a list of things that we think are helpful if you're really going to be doing a lot of work within the JavaScript API. There's some helpful links to have maybe in a bookmark folder or something to quickly find the code editor, to quickly go to the data catalog and search for data sets, read up on the developer's guide, and then the developer's forum where you can go to post questions. And I'm pretty sure if you follow the link to that, you can get access to it. But if anyone is interested in getting access to the forum but doesn't have it, let us know. We can help you get that because it's a great resource. Then we have the learning resources that Catherine linked to. And then particularly these going further links are helpful, particularly if you have a computer science background and maybe you're doing something and you're like, I would really like to optimize the parallelization of this thing that I'm doing. This thread here is really helpful to kind of learn how Google Earth Engine works under the hood and how you really don't have any access to doing any of that. And then there's a recent paper out that kind of